Okay, now this exercise number 10. Consider a triangle with sides AB 30 units and C 40 units. Always be careful because when it's given the units, you have to put them on paper, okay? If be it meters, inches, millimeters, or just units, you have to place them. Okay, now let's just draw this triangle. This is going to be an isosceles triangle. You don't have to know that, but it is going to be, right? So I'm going to draw an isosceles triangle, and there is the isosceles triangle. We just know that this angle, I'm going to write a layer, okay? Let me just acknowledge the colors. So A and B sides are the same. So A, it is 30. If this is A, this is angle A. And if this is side B, which is also 30, this must be angle B, okay? Actually, it should be inside. I just put it outside to make it simpler. Now, this angle in here, it is the same as this one. You have to know this because it is an isosceles triangle, okay? The first thing you have to know. Let's not calculate things unnecessarily. Now, C, it is just 40. And this is the angle C. Okay? Now, our triangle is done, but we have seen that we have no internal angle at all. We don't have any. All we have it is the outside. So it's going to be useless for us, the law of sines, because for law of sines, remember we have sine, sine, sides, sine, sides, sine, sides. We gotta have at least a pair of a sine, an angle, to get the sine and the sides. We don't have that, so it's going to be useless, the law of cosines. Well, it is for that case that we are going to use the law of cosines now. Okay, so let's also put the theory here. This is going to be the law of the cosines. Okay, let's just put cosine like this, the law of the cosines. Okay. And the important thing about this law is this. Oh, a little bit. Okay. The important thing is this. We're going to use this law every time we have two sides and one angle, okay, in between, or just three sides, okay. But before, let me just write, okay, all the three formulas in here. Okay, and here are the three formulas that belongs to this law. And I'm just going to write in here when are we going to use this formula? We're going to use this formula in two situations. The first one, when we have two sides and one angle in between those sides. Or we can also use this formula when we have all three sides but no angles. Well, what about if we have an angle? Well, if you have all three sides and an angle, you are going to use the law of sines, right? You are not going to use this formula because it's much more complicated to use for. When you use the law of sines, it is just cross multiplication. It's very easy. Okay? Well, what is going to be the strategy in here? We gotta have a plan, okay? Don't start making exercise just substituting formulas. You have to make a plan. Well, we're going to use the law of cosines first to get at least one angle. Once we get that angle, if you want to, you can continue working with the law of cosines, or as soon as you get the first angle, you can go straight to the law of sines and do from there. I'm going to do both ways, okay? Okay, now before we continue, I would like to make a small notation in here. we have to be careful about something about this law of sine, not about the law of cosine, but I'm going to explain everything. Let's start with the easier case, which is the law of cosine. So law of cosines. When you're using this law, you just have to understand something. There is something within this law. Well, when you're going to use this law, well, let me put here this law, and the other one is going to be here, or I'm not going to have space. This is going to be the law of cosines, and this is going to be the law of sines. This is the problem, the law of sines, okay? This is going to be the one that you have to be careful, the law of sines. But I'm going to explain both of them. Okay, what I want to explain is this. Well, here we have our circumference. Oh, let me put it this way, I think it's better. Like this. Okay. Oh, I have the reflex. Okay. So 1 second. Okay, I'm just going to pull that page in here, so I think it's easier for you to understand. Okay, let me put like right here, something like this. Okay. So when we are using the law of cosines, well, let's imagine that our cosine that we are seeing, it is this one. Let's suppose that the cosine of alpha, it is just like half. Okay, well, cosine of half, and this is going to be the cosine, this one. Now, cosine of half, what is going to be? This half, right? So go in here. This is going to be one possible solution, and this is also cosine half. We have another arc in here. We're going to have two solutions. This one is going to be theta 1, and theta 1, it is going to be 60 degrees. Okay, so alpha can be two possible cases. So alpha can be theta 1, which is 60 degrees, and it can also be this value in here, because both are going to bring the cosine of half. So, and this one is going to be that one. This is going to be theta 2, and theta 2, it is going to be 300 degrees. Okay, now we are using the law of cosines to calculate the internal angles of a triangle, and we know that we cannot have anything greater than 180 degrees. So any other option, even if you have a cosine, a negative cosine of minus half, is going to be in here. Okay, let's suppose the cosine is minus half, is going to be minus 120 degrees. The other option would be in here, down here on the third quadrant, and it's not possible. Okay, so any other option that the cosine might bring to us, it is going to be greater than pi. So the second option, it's never going to be an option, so you don't have to worry about it. Okay, it is always one option of angle when you use the law of cosine. There is no way how to make a mistake on that. And the reason I'm saying this, because of what I'm going to explain here, it's better to start using the law of cosine with the biggest angle, but I'm going to explain why. Okay, now let's see the law of sines. Well, when you're using the law of sines, things get a little bit more messy. This is going to be the sine. Okay, now let's suppose we have a sine alpha alpha. Let's suppose it is square root of 3 divided by 2. Therefore, our alpha, it is going to be what? Again, we are always going to have two values, but the second value for the law of cosine is impossible for the triangle. But the law of sines is totally different. Square root of 3 divided by 2. Well, this is going to be up here. Okay, so we're going to have one possible solution in here, and the other is going to be this one, because both are going to bring to us a positive sign. Okay, so let's put the first one. This is going to be the first angle, and this angle let's call theta 1, and theta 1 it is going to be 1 2 3 60 degrees. Okay, so theta 1 it is going to be 60 degrees, and the other angle is going to be that one. Okay, this is going to be the other angle. This is going to be theta 2, and theta 2 it is going to be the supplementary. Okay, 120 degrees. Now you see, we can have both of them inside a triangle, so both are good options. I mean, of course one of them is going to be true, we have to see, but you have to analyze. Okay, maybe the alpha you are calculating is 120 degrees. It's not going to be this one, so just be careful about what are you stating. Okay, when you use law of sines, if we have an obtuse angle, meaning an angle greater than 90 degrees, just be careful because you might have two different options. Okay, but if you're just using the law of sines just to get the sides, the lengths, don't worry about it. But when you're using the law of sines, it's more uncommon, okay, because it's more trickier for the student. But if you're using law of sines to calculate angles, be careful, because one of the angles might not be this one, it might be this one. Okay, just be careful. And how we're going to get that in the exercise? You're going to have to decide analyzing the data, okay, that is given to you, or maybe analyzing the lengths, okay, the sides. Is going to have a clue, but you gotta be careful about it. And that is why, because in this exercise we are just interested about you calculating the inner angles. Well, to get away from this mess, it's always better to to get away from this mess. It's always good to start the law of cosines with our biggest angle, because if the biggest angle, it is the only one that might be an obtuse angle. Once you find the obtuse angle, the others must be an acute angle, okay, smaller than 90 degrees. This seems a little bit confused, but this is very important. Okay, if you never got this problem, it's because you had a very good and not very good, but you have a very how can I say, calm teacher. Okay, but there are some teachers, and I would be one of those. Okay, you can bet that on my tests, if I present a problem on a very important exam, of course I am going to put an angle that is going to make the student, if he's using the law of sines, he's going to have to think about it. Which one is going to be? This or this one? So in order not to get into this trap, when you're using the law of cosines, always take the biggest angle. Okay? And if the biggest angle, it is not an obtuse angle, no problem. So none is going to be. It's going to be much simpler. You don't have to think in the bigger case. Okay? Now, how are we going to get the biggest angle? Well, the biggest angle, it is going to be the angle opposite to the biggest side. Remember, the more we open the sides, the bigger the length gets. So we are going to start the law of cosines by calculating C. So we're going to have this formula here. We have A, B, C, and we're going to get C. Okay, now it's going to be very straightforward. Okay, I just wanted to put in here something. So the law of cosines, just one possible angle. Okay, just one possible angle. For the law of cosines can be two angles. Of course, you have to choose one of them, right? A triangle has one specific angle. Now, once that it is explained, now let's do the exercise. And for now it's going to be very quickly, okay? I'm going to write everything. I'm going to present because the video is getting too big. Okay, let's just continue with the exercise. I wrote everything, so it's faster. Now, now let's apply the law of cosines to find the biggest angle. That's our aim. Okay, I'm not saying there is going to be an obtuse angle, but if there is, it is going to be found by the law of cosines, because if we have to find the obtuse angle by the law of sines, we might get in trouble. Okay, so to avoid that, let's get it on and use the biggest angle in here. It might not be on the obtuse angle, the biggest angle. I'm not saying it's going to be, but if our triangle has one obtuse angle, that is going to be the one we're going to get it first. Okay? Now, by knowing that, we're going to get C, because C has the biggest length. Okay? Sorry. Then we're going to use this third formula. Okay? And so the angle C, it is going to be the inverse cosine, or the arc cosine of C squared minus A squared minus B squared divided by minus 2AB. Okay? Well, we know ABC, it's all given. And in the end, we're going to get 83.6 degrees. Okay? No problems. Again, make sure your calculator is set to get degrees or radians. Okay? You have to put the calculator so you know how it's going to be the answer. I mean, it's going to be in radians or degrees. Okay, you don't have to use the law of cosines to get all the angles, but if you do, it is using the law of cosines, you don't get any problems by getting the angles. Okay, so once you found this angle in here, 83.6 degrees, you can continue applying law of cosines to all these other two angles, or once you know that C, it is 83.6 degrees, well, you can just start working on the law of sines. Okay? And once you know, because this is the law of sine, but until you don't know any angle, it's worthless. Now that you know this angle, we know this, right? We know this fraction. Let me just read in here. Using the law of sines, once we got one angle, this one, from the law of cosines, we can now start working on the law of sines. And by knowing this fraction, we just do the math, okay? And just like I said, you don't have to calculate A and B. They are the same. We know that, okay? It's pointless to lose time on an exam just calculating things we already know. Okay. Now, one thing is very important. So our answers, it is going to be this, right? It's going to be that angle. It's going to be that angle. It is going to be that angle. The three angles. Sum them up. Try to see if it is indeed 180 degrees. Okay, because maybe you are rounding things differently, and maybe the exam is very strict, and you might get a miss in here. So make sure everything is correct. It must sum up at 180 degrees. Okay, and once again, you don't have to do everything using the law of cosines. Once you get the first one, you can go to the law of sines. I prefer to do everything using this because you're going to have to use a calculator in here. Okay, it's impossible not to use. You have to use it. Once you have the calculator, it's much easier just to plug in numbers and calculate. Then start to a different process. This is my personal opinion. Okay, so that's the exercise.